we are going to discuss the topic electrical properties of solids. Electrical properties. Already we know crystal shows different properties due to dislocation, due to defects. When observe defects in solids, crystal shows different behavior. Electrical property, magnetic properties, dielectric properties, different properties changes due to defects. So we can say defects in solids also one advantage for us. That's why we are making a perfect crystal to imperfect crystals. When the crystal will be imperfect, it shows different characteristics. In electrical electrical properties means conductivity. The conductivity of any materials depends upon the availability of electrons, free electrons. If free electrons are available, then it gets excited to next higher energy level, then it shows electrical behavior. We know atom has two orbitals. This lower energy orbital, this is called your valence band. Valence band means band. You know, band means combination of orbitals forming a band. Valence band contains electrons, and this is called conduction band. Conduction band means when electron jumps to conduction band, then it shows electrical behavior. When this band will be just touching one another or overlapping one another, if the conduction band overlapping with the valence band, this is your valence band, this is your conduction band, when they are overlapping, then electron will be easily shifted from valence band to conduction band. And easily shifting means this type of materials is called a conductor. Because easily electron can be transferred. That's why it is called a conductor, where the conduction band and valence band are just touching to each other, overlapping to each other. Then when the gap is very less, if very less gap, here already overlapping, here not overlapping, very less energy gap. This is called semiconductor. Semiconductor means conductivity is very less, but conductivity of semiconductor increases by increasing temperature, because this gap will be reduced. When it will be heated, the gap will be reduced, electron can be shifted from valence band to conduction band. That's why it is called a semiconductor. But when the gap will be more, if the gap is more, valence band and here conduction band. If more gap, then electron cannot be easily shifted from valence band to conduction band. That's why it is called insulator. Insulator. And this gap, larger gap, is called forbidden gap. Forbidden gap. It is called forbidden gap, where the energy gap is more. That's why electron cannot be transferred from valence band to conduction band. So this is called band theory. We can say it is called band theory. If band theory will be asked, you will explain like this. On the basis of band theory, there are three types of substance. One is conductor, semiconductor and insulator. Conductor, you know, metals. Examples are metals, are some conductors. Semiconductor, you know, silicon, germanium. These are the semiconductor. Insulator, bad conductor, your diamond. Non-metals. These are the insulators. So this is about your electrical properties. Mainly, crystal shows this type of properties due to defect. Why we are discussing the properties? Because already we have discussed defect. Due to defect, crystal shows this type of behavior. Maybe electrical behavior, maybe magnetic property, maybe dielectric property, like this. So let us now discuss regarding the semiconductor. So what is semiconductor? Semiconductor is also a conductor, but electrical conductivity is very less compared to conductor. Very less. But electrical conductivity of semiconductor can be increased by heating. What are the semiconductor? Semiconductor, you know, silicon. Silicon, germanium, they are tetravalency. Valence electron 4. Then here one silicon, here one silicon, like this. Join. Silicon atom. Join one another by sharing of valence. It shows electrical conductivity but very less, very low electrical conductivity. When it will be undergo defects, then it shows electrical conductivity. Electrical conductivity can be increased when this will be converted to impure crystals. Conductivity will be increased. But in a pure state, pure silicon is a bad conductor. Generally, it is a bad conductor. So, how it will be impure? How it will be converted to impure crystal? So that it shows the defects. Generally, semiconductor are two types. One is N-type semiconductor. Second one is P-type. In N-type semiconductor, what happens? How it is produced? And the semiconductor generally prepared from a perfect crystal by doping method. The method is called doping. Called doping. What is doping? Doping means addition of impurity to the pure crystals. That is called doping. Some impurity will be added to the pure crystal. That is called doping. So how N type and P type semiconductor are produced? Why they are called N type and P type? We will discuss. We know silicon is a pure crystal which is a bad conductor. So these are the arrangement of silicon atoms forming covalent bonds with each other and the crystals are formed. But when silicon will be doped with boron, doped with antimony, nitrogen, phosphorus or arsenic, antimony. When silicon valence 4, it will be doped with arsenic. Suppose here arsenic is replaced by silicon. When we are adding arsenic to the silicon during preparation of crystals, we have added arsenic to the silicon. That already we have discussed in the defect. That is impurity defect. Already we have discussed. Similarly, it is also called impurity defect. We are adding arsenic to silicon, pure crystal silicon. Then as arsenic has 5 valence electron, then what happens? One extra electron remains around one arsenic. Clear? So around arsenic, one extra electrons remain because arsenic valency 5 and silicon valency 4. So arsenic has a pentavalent and silicon is a tetravalent. So tetravalent means silicon can form how many? 4 electron. Then 1 electron remains as a free electron. This free electron which is negative charge, that's why it is called N-type semiconductor. N means negative. Free electron, that is negative charge, that's why it is called N-type semiconductor. That means when you add higher valency to the lower valency, then N-type semiconductor is formed due to availability of free electrons. This extra electron available can be used as a current carrier. That's why it is called N-type. Then come to P-type. In P-type what happens? Here I am discussing what happens. Here, same silicon crystal you take, then you add boron. Or gallium, add boron atom, or gallium. When you add boron has valency 3. So what happens? One electron will be shortage. One electron will be shortage for the boron, for the formation of covalent bond to silicon. That means in case around boron, when boron would be added, boron has 3 valence electron. So 3 valence electron will form 3 bond with adjacent silicon. Then for 4th silicon, boron has deficit of electron. It is clear? So boron has 1 electron deficit for the formation of covalent bond with adjacent silicon. That's why it is forming a hole. It is forming hole. Hole means positive. Hole means positive. So when lower valency added, forming p type semiconductor. P means positive. When lower valency will be added, forming p type. When higher valency added, forming n type. So this is the main important features, that how you can form n type and p type semiconductor. It depends upon the nature of impurity added. So you can write this point, that what lower valency impurity, write down, lower valency impurity produces p type semiconductor and higher valency impurity produces n type semiconductor. So in n type semiconductor, the current carrier is electron, and in p type semiconductor, the current carrier is holes. So large number of holes, large number of free electrons are produced when you add a large number of impurity to the pure crystals. So this is called also impurity defect. Impurity defects of two types, that is, by using impurity defect we can produce n type semiconductor and p type semiconductor. Why we are forming semiconductor? Why we are making semiconductor from pure crystals or perfect crystal? Because perfect crystal is a bad conductor. When we are converting to semiconductor, it behave as a conductor. Then this p type semiconductor, this conductor is nowadays used in preparing diodes, making diodes. Diodes means sandwiching p with n or n with p. When mixed with p with n or n with p, then it behaves as a diodes. You know, we are using diodes in electronics, in different forming, preparing different types of electronic devices, diodes. So diodes can be formed by using p type and n type semiconductor. You have to sandwich p with n or n with p, forming diodes. Diodes are used as a rectifier. What is the role of diode? Now we use a rectifier. Similarly, if p and mix with n and p, that means you or NPN, that means just you sandwich between P1 N type or between N1 P type, then you will form, what is this? Transistor. These are called transistor. Transistor used for making electronic devices. So diodes and transistor are made of semiconductor. What type of semiconductor? P type and N type semiconductor. So these are the formation of semiconductor. So similarly, other physical property can be observed from crystal. That is, magnetic property. Magnetic property of the crystal. Electrical properties and magnetic property. Magnetic property, you know, magnet, it has magnetic movement and different type of magnetic can be produced. So, how the crystal behave as a magnetic property? When it undergo defects. When it undergo defects, it also behave as a magnet. How it will be imperfect? Already have told you, either by heating or by electrically or placing a crystal near magnet, you can show magnetic behavior of the crystal. The crystal, the behavior, magnetic behavior can be observed when the crystal will undergo heating or electrically or when it will be placed near magnet. It is shows magnetic behavior. Magnetic behavior, you know, all atoms made of electrons. Atom also contains electron. Electron also can be revolve around the nucleus or can also spin. Spinning of electron and the revolving electron undergo magnetic field. Electrons of atom has magnetic field due to revolution and spinning. It behaves as a bar magnet. It behaves as a bar magnet. Means electron behaves as a bar magnet. Atom also behaves as a magnet. Electrons also behave as a magnet. Means it has magnetic movement. It has magnetic movement. Magnetic movement is measured. The magnetic property is measured by magnetic movement. So what are the behavior of crystals? What are the different magnetic behavior of the crystal? Let us discuss. Magnetic behavior generally different types. First, it is diamagnetic. Diamagnetic crystals. Diamagnetic crystal means it is weakly repelled by the magnet. Magnet will repel the crystal. That is your diamagnetic. And what are the other characteristics? Having unpaired electron. No unpaired electron. Unpaired electrons should not be available. Means what happens? The electron, the magnetic movement produced by electron will be one electron will be cancelled by the magnetic movement produced by other electron. Cancel each other. That's why it will be as a bar magnet. They use as a diamagnetic substance. What are the example of diamagnetic substance? That is sodium chloride, water, benzene. These are the examples of diamagnetic substance. Means they will be repelled by the magnet and they have no unpaired electrons. This is the characteristic of diamagnetic substance. Then second type of magnetic substance are paramagnetic. Paramagnetic. And the property is called paramagnetism. The substance showing paramagnetic behavior are called paramagnetism. Substance is called paramagnetic substance and the property is called paramagnetism. What are these here? And what happens? They have weakly attracted. Weakly attracted and having unpaired electrons. Having unpaired electrons. Here, having unpaired electrons so that they will not be cancel each other. That's why magnetic movement will not be cancelled. And what are the examples of your paramagnetic substance? Examples are ferric ion, chromium ion, oxygen. Here also we can write nitrogen also, diamagnetic substance, nitrogen, here oxygen. These are the paramagnetic substances. What are the property? Main characteristic is they will be weakly attracted, not strongly, because weakly strongly depends upon the magnetic movement produced. Third one is ferromagnetic substance. Ferromagnetic substance, here generally what happens when the crystal is produced by the combination of atoms or molecules, each atom or molecule considered as a domain. Combination of atoms called domain. Behave as a domain. Each domain has some magnetic moment. And the magnetic moment produced by the domain, when the substance will be placed in magnetic field near a magnetic source, then this type of substance will be strongly attracted. This is the characteristics. Strongly attracted. And the magnetic moment of domain will be in parallel alignment. Like this. Magnetic moment will be in parallel way. The magnetic moment produced by the domain will be parallel to the external magnetic field. Where already I have told you the substance behaves as a magnet. I can study where it will be placed near magnetic field, outing source. From the external magnetic field you have to bring to the atom. Then it shows the different view, either diamagnetic or paramagnetic or ferromagnetic, like this. Ferromagnetic means that in domains, magnetic moment produced by domain and external magnetic field will be in parallel manner, parallelly arranged. And what are the examples of ferromagnetic substance? Examples are iron, chromium, nickel, like this. These are the ferromagnets, iron atoms, chromium atoms, nickel atoms forming the domain. The magnetic moment of these atoms will be aligned parallelly with the external magnetic field. That's why they will be strongly attracted to magnetic field. One important characteristic, ferromagnetic substance, they continue show its behavior when external magnetic field will be removed. This thing also we can write. The magnetic moment exists after removal of magnetic field. But in paramagnetic, when the external magnetic field will be removed, then suddenly it will lose its magnetic moment. This is the difference between ferromagnetic and paramagnetic. It will be lose. It will not lose its behavior, but in paramagnetic it will lose its behavior in absence of magnetic field. And ferromagnetic can be converted to paramagnetic by heating. That temperature is called Curie temperature. By Curie temperature, we can convert ferro to para. Ferro can be converted to paramagnetic by this temperature. And exact temperature required so that ferro will be converted to paramagnetic. Then another type of magnetic substance are antiferro. Antiferromagnetic substance means here the magnetic movements produced by the domain will be in opposite manner. Means they are aligned in opposite manner so that they will be cancelling each other. Antiferromagnetic substance, their domains, magnetic movement of domains will be in opposite manner, so that they will lose the magnetic property. What are the antiferromagnetic substance? Example is manganese oxide, MnO, manganose oxide. MnO is example of antiferromagnetic substance. One important is magnetic movement are in opposite direction. This thing you have to remember. Then last one, the magnetic delivery is ferrimagnetic substance. Ferrimagnetic substance, here magnetic movements are aligned in unequal alignment. Unequal alignment means like this. Here one upward, here downward, and the three are upward. Not in equal, just not in opposite. Either equal or opposite or unequal. Here unequal alignment. It is called unequal alignment. Unequal alignment. Unequal alignment of the magnetic moments resulting ferrimagnetic substance. Examples are Fe3O4, ferrosulfuric oxide. Fe3O4 is the example of ferrimagnetic substance. So the magnetic behavior of the substance depends upon its composition and the nature of atoms forming the crystals. Okay, thank you.